Lesson 1.6 is limits and end behavior. So what we're going to be looking at is how a graph behaves on its far ends, far left and far right, and also how it behaves around any unusual features. So what we mean by unusual are any vertical or horizontal asymptotes. Remember, asymptotes are lines that a graph will approach but will not cross. So for vertical asymptotes, we have two. We have one at the vertical line here, and we have another at the vertical line here. So vertical lines use equations x equals. And so our vertical asymptote, one of them is x equals -1, and the other is x equals 6. For horizontal asymptotes, again, the graph won't cross that asymptote, but there's a catch we're going to talk about. So the horizontal asymptote here, use y equals for those, is y equals 3. Now, the domain of any graph breaks up at vertical asymptotes or any other holes or gaps. So with two vertical asymptotes, there's going to be 3 sections of the domain. One of them domain will go from negative infinity to the first vertical asymptote at -1. The next section will be between the vertical asymptotes, -1 to 6. And then that last section will be from 6 to infinity. All of those are parentheses because we never touch any of them. We never can touch infinity. And then at vertical asymptotes, the graph absolutely cannot cross those. Now, this particular horizontal asymptote at y equals 3 does break up the range. So the range of this graph, okay, if we look at that horizontal asymptote, the middle section of this graph does actually cross it. So there is actually not a gap in the range. This range does go from negative infinity to positive infinity, or we can write that as all real numbers. Now, the unusual thing about this horizontal asymptote is that the graph does cross it. The graph does cross that horizontal asymptote. Okay, but not on the far left and right ends of the graph. And that's what horizontal asymptotes are going to do. The graph will not cross the horizontal asymptote at the ends of the graph. The ends of the graph, the far left and the far right, are what the graph will approach the horizontal asymptote, but not cross it on the far ends. So this leads us into finding some limits. This limit notation, there's a lot going on in here. It's the limit of f of x is y, as x approaches -1. -1 is going to be a vertical asymptote. Okay, the plus here means on the positive side, so on the right. If that were a negative, it would be on the left. Okay, so the limit as x approaches -1, again, the second one, that -1 is a vertical asymptote, and that negative here means on the left. Okay. If we have a limit with positive and negative infinity, we can find those limits as well. What this means, find the end behavior, the limit, as the function approaches the far left. That's as x is approaching negative infinity. So as the x's get closer to negative infinity, what's happening to the graph? Same thing for positive infinity. The end behavior is the graph approaches the far right. Positive infinity is the far right. So we're looking at the far right behavior. So on the graph given, okay, these first two limits, A and B, are asking about that vertical asymptote at x equals -1. So look at the graph as x is approaching -1. Because x equals -1 is a vertical asymptote, the graph will not cross it. Now, here's a way we can help ourselves out with this. At the vertical asymptote, at the very top and at the very bottom, we're going to label left side, right side. And we're going to do the same thing on the bottom. I'm going to label the left side and the right side of that vertical asymptote. Okay? And if we look at the graph, as x is coming close to -1 on the left from the negative side, okay, as this x is getting closer, our y's end up going down, 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 down. So on the left side, if we notice on the left side of the dashed line, the graph goes all the way down. On the right, there's nothing there at the bottom. So that limit on the left side of -1, left side of x equals -1, is all the way down. That's negative infinity. So that limit is negative infinity. Think about the same thing coming from the right as we get close to -1 on its right. So going towards the right side of that vertical asymptote, we're going up. So notice here on the right side of the vertical asymptote, the graph goes up. On the left side of that vertical asymptote, nothing is there. So on the right, that asymptote goes to positive infinity. So this second limit is positive infinity, or just infinity. It's on the right side of x equals negative, and that -1 got cut off. Now, let's look at the limits at the other vertical asymptote. C and D are asking you about the limits at the vertical asymptote at x equals 6. That's what x approaching 6 is indicating. So at the vertical asymptote at x equals 6, label the top, left, right, label the bottom, left, right. Left and right of that dashed vertical line, that vertical asymptote. Now, as we look on the left of this asymptote, the graph is going down, 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 down forever. So on the left of that asymptote, the graph is going to negative infinity. On the right of that asymptote, that graph is going up, 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 up on the right. So that limit on the right is positive infinity. Now, let's talk about the infinite limits. Limit as x approaches negative infinity. This is the far, far left edge of the graph. What's going on the far, far left of the graph? So, on the far left, this is where x is approaching negative infinity. We have this horizontal asymptote. So the graph is going to keep approaching that horizontal asymptote, but never touch it. So that limit as x approaches negative infinity is that horizontal asymptote, which is y equaling 3. So that limit is 3. Now, on the far right, as x approaches positive infinity, that is the far right of the graph. So if we look at the far, far right of the graph, that horizontal asymptote continues. That graph will go all the way to the right, but not cross that asymptote. So again, that limit is 3. More examples.